Hello, welcome to this short video presentation on case study on corrosion failure. My name is Dr. K. Ilaya Perumal. I am a corrosion and metallurgical consultant. Reasons for corrosion failures can be due to different deficiencies. Some of these deficiencies are design, material of construction, metal quality, process control, process impurities, and process treatment. A group of chemical companies has made a survey of the various reasons for corrosion failures in chemical process industries. You can notice the maximum number of failures have been due to design. There are other causes like lack of protective treatment, quality in materials, quality in operating parameters, loss of awareness, etc. We will talk case studies arising from some of these causes. Case study number 1 deals with the leakage due to corrosion of tubes in a waste heat boiler. Waste heat boilers are heat exchangers. They are used to extract heat from process gases to create steam, which is required for different purposes within the plant. So waste heat boiler is a very important process equipment in chemical process industries. In this particular case study, we will analyze premature failure after only 4 years of service as against 30-40 years of design service. This premature failure resulted in tubes leakage. Waste heat boiler is again a heat exchanger in which tubes are used for transferring the heat in a shell and tube heat exchanger design. This is the typical design of the waste heat boiler which has given problem. What you are seeing is the elevation. What you are seeing is the elevation of the waste heat boiler. The hot gases enter the tube side at 405 degrees centigrade, and then it travels upwards and then exits at 333 degrees centigrade and on the gas outlet nozzle on the top. The remaining, the balance 72 degree centigrade heat is given to the boiler water, which enters at 315 degrees centigrade in this nozzle S1, S2, and this water circulates around the shell side and leaves as water and steam at this nozzle at 315 degrees centigrade. This excess heat from the gas is given to water to produce a steam at the same temperature. So this steam is utilized for various purposes. This is a cross section of the waste heat boiler. This boiler is made of low alloy steel, chrome moly alloy steel. This is much better compared to carbon steel with respect to high temperature properties and also certain resistance to corrosion. You can see among approximately about 1,000 tubes, quite a number of tubes leaked. So this is a cross section showing the number of tubes leaked. This is a close-up of a certain representative tubes which leaked. You can see on the right side, this is the uncorroded end of the leaky tube. This is the top side where the temperatures are slightly lower, whereas on the left side you can see the corroded end. This is at the bottom. I must repeat, this is from the same tube which leaked. Leakage occurred at the bottom, and the top side there is no leakage. And you can notice the inside diameter is very uniform. Inside surface is very uniform. You can see the inside surface here also uniform, whereas the outside surface is very smooth on the uncorroded end, whereas on the corroded end, outside surface is very rough. This indicates that corrosion has taken place on the outside surface. And you can recall the outside surface contains boiler feed water, whereas the inside surface contains hot gases. So this indicates there has been some corrosion problem on the outside surface. That means the boiling water. This shows the longitudinal cross section of one of the leaked tube. The outside corroded surface, you can see very rough corroded region, whereas on the inside surface you can see relatively corrosion free, somewhat smooth surface. So this inside surface is exposed to the gas, the outside surface is exposed to the boiling water. So this phenomenon of corrosion has led to the leakage. This sharp type of corrosion problem is called caustic gouging. It is caused by heat transfer and poor circulation of boiler water at the location. Any condition leading to formation of high temperature caustic will lead to this type of gouging problem. So the diagnosis is caustic gouging at the bottom side. This is a sketch of the failed tube. You can see the tube sheet, which is a plate of about 228 mm thickness, and the tubes are drilled and expanded into the tube sheet, and you can see the position of the leakage is about 240 mm from the tube sheet outside surface. From the inside surface, around 15 mm, 240 minus 228, 12 mm layer of water has been remaining, and that layer has led to this corrosion. And this layer in a boiler water is alkaline. That is why it is called caustic gouging. And you can see in the next slide the positions of the various nozzles. So the diagnosis is caustic gouging due to stagnant boiler blowdown water. This boiler blowdown water has remained stagnant on the shell side. Slowly the concentrated alkali has increased, leading to caustic gouging. This slide shows the flow pattern, of course schematic, of both gas flow and water flow. Gas enters at the bottom at 405 degrees centigrade and leaves at the top at 330 degrees centigrade. Water enters at 315 degrees centigrade, goes around the shell and goes out as water and steam at the same temperature, 315 degrees centigrade. The latent heat to produce steam is taken from the hot gas. So this is the flow pattern schematic, and there is a blow down water getting stagnant at the bottom, and there is a blow down exit. So this problem has resulted in insufficient blow down, resulting in stagnant water. So this is the cause of the corrosion problem experienced. The stagnant alkaline water has resulted in corrosion of the tubes. So having seen the deficiency of the design, the recommended action was a improved design. On this improved design, you can notice at the bottom area, the drain, the blow down drain is given flushing with the tube sheet surface. There is no stagnant water in the bottom area where the tubes have failed earlier. So this modification of removing the stagnant water has resulted in preventing the failure of the tubes. Blow down exit flushing with the tube sheet surface. So there is no stagnant layer here. The blow-down connections are given in detail in this slide. You can see in the old design, there is only one blow-down exit coming from the center, and there is a blow-down connection taken from the center of the exchanger, and this is not sufficient to take all the stagnant water. So in the new design, the blow-down connections are given in the periphery of the tube sheet at equi-placed so that all the stagnant water goes out without remaining within the boiler. And also you can notice these connections are flush with the tube sheet surface. The flush with the tube sheet surface means it doesn't allow any stagnant water to remain on the tube sheet. So this is an improved design ensuring removal of blowdown water uniformly throughout the cross section, and this resulted in better performance. So recommendation, any case study should end up in a recommendation. Diagnosis means stating the root cause of the problem. Recommendation means how to avoid such problem in the future. So in this case, it is a design fault. So we should not allow stagnation and buildup of caustic solution within the boiler, anywhere on the boiler. In this case, it has built up on the bottommost. That is why the tubes failed in the bottommost position. So in that position, we should provide sufficient number of blowdown tappings. So this is the recommendation for this failure. The takeaway on this particular small video presentation of a case study, we have seen corrosion of tubes in a waste heat boiler, and that resulted in caustic gouging due to lack of design. So this is a typical case of design deficiency of corrosion failure. So this design deficiency corrosion failure has to be corrected, and that is what this video lecture has given us. Thank you for attending this case study on corrosion failure. In this slide, you will see the title of the book written by me and Professor Raja named Corrosion Failures. You can get details in this book. The book has been published by John Wiley USA, and you can get this book through Amazon. Thank you.